Okay, Unit 3 examines perceptions of risks and threat appraisals in humans. There's three different presentations. I've broken this up into three smaller units so you don't have one long lecture to listen to. So make sure you listen to all three presentations. This first one looks at cognitive heuristics and biases and how they influence our perceptions of risk, in particular information security risks. Ultimately, what we want to do is relate perceptions of risks to organizational vulnerabilities. Here's a list of common attacks on information or computer networks. Okay, the top ones I would sort of loosely call engineering or technology vulnerabilities. At the bottom, we have psychological vulnerabilities. So at the top, for example, IP spoofing attacks is where when a hacker steals an authorized internet protocol IP address. This is typically done by determining, the IP address of a computer and sort of waiting till no one's using the computer and then using that inactive IP address. Packing sniffs are when the hacker listens to the transmission control protocols, the TCP/IP packets, which come out of a network, and steals the information in them. Typical information that the hacker is looking for: logins, email messages, credit card numbers, etc. Session hijacking is when a hacker taps into a connection between the client and a server. The hacker then simulates the connection by using the IP address, etc. Many of you are in the IT world, so probably understand these better than I do. I'm more focused on the psychological vulnerabilities. Password attacks and social engineering, and that's what we'll relate this unit to, and especially as we go forward in Unit 4 when we look at phishing in more detail. But in terms of password attacks, this is a common weak point in any system. Hackers generally find a user with an easy password or use a special program which cycles through a range of words from a dictionary. The worst nightmare of this type of attack is when a hacker determines the system administrator's password or that of a user that has system privileges. Social engineering, another term for phishing in essence. These are attacks that are aimed at users who have little understanding of their computer system or network. A typical attack is a phishing attack where a hacker sends an email message to a naive user asking for their password. Posing as PayPal, saying you need to update your account, for example. So these are psychological vulnerabilities to the naive users, or the users of the system need to perceive the threats and the risks involved in their activities to prevent these. The fact that they're not great at perceiving risks leaves the system vulnerable. Okay, so this quote, which I've given you before, or variations of it, is from Ross Anderson, and it captures the feeling of many security experts today. Basically, the easiest way to hack into an organization is through its people. The main point of this lecture is that people typically act intuitively based on perceptions of their immediate environment. We have mental heuristics that guide our decision-making and judgments. These heuristics work well in most situations, but they also represent vulnerabilities that savvy hackers or intruders can take advantage of. Let me emphasize, however, it's not that we reason poorly. It's just that we often don't use the full reasoning power of our brains. Okay? All right. Today we're going to focus on this section here of the presentation. We'll focus on heuristic thinking, which I introduced you to back in our Psych 101 overview really quickly. So recall back then in Unit 1, we made a distinction between System 1 and System 2 modes of thinking. System 1 is a system of associative activation. Your mind unconsciously searches for meaning by pairing events with associated ideas or events in memory. System 1 works through spreading activation in the brain. Ideas that are evoked activate other ideas, and System 1 tries to make a coherent story out of them. Through association, System 1 links the present with the past and establishes expectations about the near future. This is intuition. Okay, it's quick and it's somewhat automatic. It often goes on, outside of your awareness. System 2 allocates attention to effortful mental activities, It can compare objects and several attributes. It can follow rules. It can make choices. And one of its main functions is to monitor and control the thoughts suggested by System 1, to check their accuracy. But a critical point you may recall is that System 2 is lazy and mental effort is aversive. System 2 is supposed to check the accuracy of System 1 impressions, but it often accepts them too quickly. As I said, we're going to break this into this overall presentation into chunks. You'll see if you go across the presentations, there's 3 aspects to intuitive action. One is heuristic thinking, which we're focusing on today. There's also perceptions under uncertainty, which is prospect theory, and then there's also framing effects. That should be a third separate bullet there for framing effects. We'll get to the second and third in our other presentations in this module. Okay, so the defining characteristic of intuition is that they come to mind spontaneously. Okay, so for example, do you trust the used car salesman? You get a pretty spontaneous impression of the person, how they initially interact with them. Do you trust that email from PayPal that comes across your desk? Now you probably react much differently to these, but when they first came across, you may have trusted it just because it said PayPal at the top, for example. So there are these intuitions that come to mind spontaneously. Okay? System 1 acts to suppress ambiguity and uncertainty. Remember, doubt is a property of System 2. The result is that we are pretty confident of our initial impressions, in some cases more confident than perhaps we should be. The mental work that produces these judgments goes on in silence in our mind. We are not aware of the source of our judgments, okay? And we are not aware that we are not aware. That's a quote from Daniel Kahneman. Again, it's sort of this notion that there's things going on behind the curtain that we're not always aware of, but give rise to our spontaneous judgments. Let me also emphasize that there is an intimate connection between experience and intuition. Okay, intuition comes from somewhere. Okay, and as Kahneman points out, skill and heuristics are alternative sources of intuitive judgments and choices. Both reflect System 1 thinking. Okay, the soccer player, for example, over time gets to read situations very quickly and knows, is this the best opportunity to dribble, shoot, or pass? Okay, it doesn't carefully cycle through and weigh alternatives. It responds intuitively and spontaneously based on experience. Same thing, another example is a chess master. They read boards very quickly, intuitively know what their opponent's next move are likely to be. So the accurate intuition of experts are produced by extensive experience and interactions with the subject material. So when you hear people say, go with your gut, I don't have a problem with that. That makes sense, as long as your gut has a lot of experience in similar situations. Okay? Novices aren't reading the situation correctly. Okay, so the essence of intuitive heuristics, when faced with a difficult situation, we often answer an easier one, usually without noticing the substitution. We typically search for intuitive solution, either an expert solution or heuristic answer. When one can't be found, then we're likely to switch to a controlled or slower mode of thinking. But if the heuristic sounds good to the system, it is readily accepted. Okay, so for example, imagine a manager deciding whether his or her organization has a good security system in place. That's a difficult decision to answer, unless there have been many breaches, in which case the answer is simple. It's not effective. But let's assume that there's not been those breaches. It's a difficult question. An easier question for the manager to answer is, do you like the system? Is it easy to use? If the answer to those things is yes, then they tend to see it as safe. That's a heuristic, intuitive judgment. Okay, so just to recap, again, a notion that we mentioned earlier this semester, the notion that when we use heuristics, we're substituting a target question for an easier question. So, for example, trying to decide whether someone would make a good leader or not, we often ask, does this person resemble or look like a leader? Is this technology safe? Is substituted with the question, do I like this technology? Will this job candidate succeed? Does he interview well? How safe is the internet? Well, do I like the internet? Again, those are the questions that we often use as a sort of a substitute, as an example. All right, so the research by Kahneman and Tversky identified dozens of heuristics. You probably, if you read Schneer's article, he went through probably at least 15 to 20 of them. Three prominent ones I want to discuss here because they also will relate to our discussions of phishing and privacy that are coming up next in the course. These three are the availability heuristic, the representativeness heuristic, and the affect heuristic. Okay, let's start with the availability heuristic. Which is likely to kill more people in the United States this year? Tornadoes or lightning? Quickly answer. Okay, are you more likely to die from a shark attack or from falling airplane parts? All right, the answer to those questions basically is lightning and airplane parts. We are more likely to get die from lightning than tornadoes. And believe it or not, and I continue to fact check this, and I continue to be amazed that it seems to be correct, is that airplane parts kill more people than sharks. Shark attacks come to mind more easily than falling airplane parts, so they are seen as more dangerous. Tornadoes are more vivid in our minds than our lightning strikes. Okay, so the availability heuristic is at work here because basically if something comes to mind easily, if it's accessible, if you can think of it, it must be important. So when asked to judge the probability of an event occurring, we basically do it by how easy it is to come to mind. Things that come to mind easily are believed to be common and accurate reflections of the real world. Another example, the effects of indoor air pollution like carbon monoxide are underestimated because of the lack of media coverage. Recalling the coverage of lottery winners leads people to overestimate their chances of winning the lottery. Again, just sort of examples of the availability heuristic. The availability heuristic is quite useful in inductive reasoning because likely events are often easier to imagine, and causal connections are repeatable and therefore more likely to be remembered. When availability in memory is associated with the objective likelihood of an event, the availability heuristic is trustworthy. So it does have its advantages. However, there are disadvantages as well, and the availability heuristic can systematically lead to poor judgments when an event or object whose instances are readily available might appear to be more numerous than in reality. So, for example, jackpot winners are probably appear more numerous to us than they are in reality. The availability of certain information may be biased because one has limited exposure to events of a certain kind, such as falling airplane parts. Events that are graphic and remarkable and noticeable, they're vivid, they may attract more attention than they deserve. So shark attacks versus bee stings. This is actually the one I always used previous to the airplane part analogy or comparison. Shark attacks are much more graphic than bee stings, but again, bee stings kill many more people than do shark attacks. All right, so the availability heuristic substitutes one question for another. You're asked to estimate the frequency of an event or size of the category, but you report an impression of the ease with which instances come to mind. Think of information security threats. How available in memory are things like password hacks or phishing emails? They're not typically highly accessible to people. So they're probably gonna, when asked to estimate the frequency of their occurrence, they are likely to be underestimated by people. So the effect of vivid memories also helps explain why people overestimate the likelihood of rare outcomes. I gave this example before about whether, if you're visiting a Middle East country, are you more likely to be a victim of a terror attack or a car accident? Well, some events like terror attacks elicit strong emotions that are quite vivid. All right, so emotions and vividness influence the fluency and availability of memories, and thus account for our excessive response to impactful but rare events. By contrast, the outcomes of information security breaches, to the user at least, may be dull and mundane. They're not very vivid. As a result, they may be less accessible in memory, and they may be judged to be non-threatening. So let's have a little look at some of the implications of availability heuristic for security and risk. First of all, the availability heuristic can explain the preparation or lack of preparation and responses to disasters. Disasters occur, and once they occur, they heighten concern about the disaster. Okay, so for example, flooding in the Capital District region became a concern in the last few years when we had some devastating floods as a result of hurricanes coming through. But that's a relatively rare event in the Northeast, and so most often people aren't thinking of floods, and the preparation for them and response to them is inadequate. But when they do occur, there's a heightened concern, and that's why you see things like insurance purchases and other protective actions will always go up after disasters. Okay, but with time, disasters become less available in memory unless they're repeated. The fact that we had 2 floods in 2 years may keep people more prepared for them. But often disasters do not occur with regularity or frequency, so they become less available in memory, and we start to downplay the risks. We become complacent. That then basically leads to a lack of preparation until the next disaster actually occurs. The other implication is that protective actions by individuals and organizations are usually designed to protect against the worst events experienced to date. We don't know what the worst flooding could be, for example, or what is the worst earthquake we can experience. But what we tend to do is to prepare for future events based on the severity of previous events. So we use the most severe, most common previous disaster as our benchmark for preparing for the future. So we assume the floods will not rise above the existing high water mark, or we assume that earthquakes won't exceed the strongest recorded to date. This can have disastrous consequences. For example, in Italy, in L'Aquila, Italy, there was an earthquake in 2009. This killed 300 residents, left 65,000 homeless, and caused $16 billion worth of damage. This is an area of Italy where it was known that there was earthquake or risk of earthquakes. And many recent buildings were built to withstand the strength of an earthquake that was recorded in 1950 that was quite powerful. However, compared to the Richter scale, it was moderate level of 5.0 magnitude. So the buildings were built to withstand that. In 2009, however, the magnitude was 6.3. Now, the Richter scale, none of us understand unless we're geologists, but 6.3 is actually 75 times more powerful than an earthquake of 5.0. So it was much more damaging or much more severe than the previous ones, and the buildings were not built to withstand that type of earthquake. Although, despite the fact that 6.3 is not nearly the magnitude of the strongest recorded earthquake. Okay. So once again, it's what's available in memory. Oh, we remember that earthquake 5.0. Let's build to withstand that. Well, then you get something that's 75 times more powerful, and you have disastrous results. Implications of the availability heuristic for information security. Risks that are highly available in memory will prompt people to take precautionary action and increase the motivation to comply with safety procedures. Risks that are not easily accessible will be judged unlikely to occur and will therefore reduce compliance with safety procedures. In the security policy context, people assess the risk of a serious security breach by recalling the number of breaches that occurred in the workplace or among acquaintances. To the extent that such occurrences come to mind easily, their perception of risk will be high. Conversely, if they cannot recall security breaches occurring to them or to acquaintances, their perception of risk will be low. Okay, so how easily we remember things or how easily threats come to mind is directly related to the actions that we take to prepare for them. Okay, the representative heuristic is another heuristic that will influence our decision making and for our concerns, for decision making under risk. This heuristic refers to the tendency of people to judge the probability of an event by finding a comparable known event, something that's similar, something that resembles the event they're evaluating, and assuming that the probabilities will be similar. So the probabilities of something that resembles the event being evaluated will be substituted for the probability of the event itself. So, for example, in a job interview, the interviewer or the hiring manager may look at the resume and say that this applicant is a graduate from a business major from the Big Ten University and president of fraternity ABC. Well, our best workers have been business majors from Big Ten universities and presidents of their fraternities. Therefore, this person will be a successful worker because he resembles those others. So you're substituting an easier question: will this person be a successful worker? Substituting an easier question: does this person look like a successful worker? For a more difficult one: will this applicant be successful? Okay, this should be familiar to you. From notions of stereotyping and profiling. Okay, we judge the probability of something by which it matches a stereotype or prototype that we have. So profiling of drivers, okay, profiling of individuals is basically based on the representative heuristic as well. There's potential for bias, obviously, because just because something is more representative does not make it more probable, does not make it more likely. We've got several examples in your Schneer reading. By the way, those Schneer just took the classic two from Kahneman and Tversky's work, that being Linda the bank teller problem. Okay, that one's reviewed, as well as the Tom W. experiment, I call it. So I'll just use the Tom W. one here, but I encourage you to read about some of the other examples in your readings. If you remember, this is an experiment where participants were given a description of an individual, Tom W., and they were asked to rate how probable it is that Tom is a lawyer or Tom is an engineer. Now, there was two conditions in the experiment. Half the participants were told that in the population from which Tom W. was drawn, 70 of them were engineers and 30 were lawyers. Okay, so base rate information would tell you that Tom is more likely to be an engineer than a lawyer in that case. The other condition was the population was from 30 engineers to 70 lawyers, so 30% lawyers, 30% engineers, 70% lawyers. Again, the base rate information there would say it's more likely that Tom would be a lawyer in that condition. Description: Tom W. is of high intelligence, although lacking in true creativity. He has a need for order and clarity and for neat and tidy systems in which every detail finds its appropriate place, blah, blah, blah. Okay, clearly written to sort of give, to match a prototype or stereotype of an engineer as opposed to a lawyer. What Kahneman and Tversky wanted to see is that would the participants be influenced at all by the base rate information? And especially under the condition in which lawyers were the minority, would they be likely to say that, engineers are the minority, would they be less likely to say that Tom is an engineer? Again, from the readings, you know that, and in fact, people in both conditions felt that it was highly probable that Tom is an engineer, despite the base rate information. That given that description, it must be an engineer. So the description is more representative of the personality profile that comes to mind for an engineer. So the subjects or the participants in this study implicitly answer the question, which is more representative of the personality profile rather than which is more probable. The profile is more representative of an engineer, but what question is being asked is what is more probable. Again, sort of note this is a sort of a general aversion that we have as humans towards probabilistic thinking. We don't think in terms of probability very, very well. So the representative heuristic is related to the fact that people tend to ignore base rate decisions, base rate information, when making judgments under uncertainty. Some of the implications of the representative heuristic. People underestimate personal risk if they do not see themselves as resembling high-risk populations. So this is critical for all types of risk. So, for example, because heart disease is more stereotypic of men, women incorrectly view the risk of breast cancer as greater than the risk of heart disease. And in fact, women are at greater risk of heart disease than breast cancer, but the attention that breast cancer gets. And the fact that heart disease seems to be more stereotypic of men, women underestimate their risk. People do not see themselves at risk for computer security breaches either. They don't fit the stereotype of the victims. People who get their computers hacked are those who aren't savvy, they're careless, they're already engaged in some sort of criminal activity like sharing of software illegally or downloading things illegally, or they're porn enthusiasts. Okay, so those are them. Those are the people who have problems with security breaches. I don't fit that, therefore I'm not at risk. Facebook users or bloggers are not concerned about divulging personal information because they don't fit the profile of the cyber stalking victims. The people who get stalked on Facebook, those are the teenagers living in the Midwest we always read about. But we don't fit that profile, therefore it's not a concern to me. All right. The final heuristic is the affect heuristic. This relates to perceptions of, the affect heuristic refers to situations when the perception of risk are influenced by emotions and feelings toward the object. This is often been referred to as affect bias in the literature. So when you see affect bias, you know that affect heuristic is at work. Here, threat is inversely related to affect or feelings or valence. Okay, such that high threat is associated with things that people feel negatively about. If I don't like it, it's risky. If I like it, it's not risky. Okay, so conversely, low threat is associated with things we feel good about. For example, technologies that are seen as beneficial are routinely perceived to be at low risk. This is a common finding in the literature. We like our computers, therefore they must be low risk. The affect bias may be partly responsible for the paradoxical negative relationship between risk and benefit in most people's mind. If you think about it, the whole notion of entrepreneurism, lots of risk, brings high reward. So there's this positive relationship that exists, at least, in economists' minds. The layperson, they're negatively related. Okay, things that are risky don't have benefit. So more generally, people with negative attitudes and feelings towards technology will perceive more risk and threat than people who have positive attitudes. So in organizations, those who may be most oblivious or most likely to underestimate the risks from computer breaches or security breaches, maybe those have the most positive attitudes towards computers. Okay, so. Another example here is from Facebook. Most people feel strongly about protecting their privacy. If you ask them, privacy is very, very important. Okay, yet they'll walk down the street, carrying on conversations for everybody to hear. They'll post or disclose personal information on Facebook readily. Why is it? They'll note concern about privacy, but yet. Talking on the phone or on Facebook, they seem to divulge information that they normally would not. So the explanation, according to the affect heuristic, is that these activities, talking on the phone, using Facebook, provide strong feelings for many people, which leads them to discount the harms that may arise from disclosing personal information. All right, one last point. then well, that's fine. Let's move on to the summary. What do you get from these review of these heuristics? Here's sort of five summary points. The amount of precaution that people take is not likely to be proportionate to the actual probability of danger or harm. Availability, representative, and affect heuristics lead us to come up with inaccurate estimates of probability of danger and harm. People are likely to think that they are not highly susceptible to risk of harm, especially those things that they feel comfortable doing. People are likely to be swayed by threats that come to mind easily, but they're going to ignore those that are not highly accessible. People are likely to exaggerate spectacular or vivid risks, again, because they're highly accessible, and the downplaying mundane risks. So the mundane is not highly accessible or vivid. And people are unlikely to see risks in things that or activities that they like. So think about this for a second. For many workers, the risks posed by information security breaches are likely to be downplayed or ignored because such risks are not particularly vivid. They do not come to mind easily. They are seen as happening to others, not them, and hence not representative of their world. Okay. All right. So finally, the question becomes, what to do? What are the implications of this? Okay, now that we know that there's these biases, that we may be prone to these biases that may put organizations or individuals at risks, what do we do about it? Well, the key point, one of the key themes from this presentation is that we act intuitively. We follow System 1 until System 2 is forced to take over. Now, System 2 doesn't jump in readily. And so I would point to the power of the situation which is driving System 1, or that may activate System 2. The field of social psychology continually shows the power of the situation over our behavior. What we perceive in the environment or the situation drives our behavior. So to trigger System 2 thinking, we may need situational cues that will activate it when it is needed. Again, note, we don't always want System 2 activated because System 1 does quite well on its own. Okay, but from a security perspective, we want System 2 activated when the threats are indeed present. Okay, so not going to give you a strong answer to this question right now because it's actually going to be part of Assignment 2. Okay, but when asked in Assignment 2, when asked what to do about overcoming these heuristics, think that the situation is what's guiding or driving System 1 and potential biases. What can we do in terms of providing situational cues that may trigger System 2 when, in fact, needed?